Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will see numerical based on Dopplers effect. So let us start with numerical number 3. Now in numerical number 3 we have a car horn producing frequency of 400 Hz is moving towards the observer with velocity 220 meter per second. The velocity of sound is 330 meter per second. Find the frequency of sound heard by an observer. Here, now find the frequency of sound heard by an observer. Given is observer is stationary. So let us start with the given quantities. Now here we have the frequency of source, that is 400 Hz. Means this is actual frequency of the source. So we'll write frequency is equal to 400 Hz. Now the car is moving towards the observer with velocity 220 meter per second. Car is moving. So here car is the source of sound. So we have here Vs. Vs is equal to 220 meter per second. Then the velocity of sound is 330 meter per second. Means V. Find the frequency of sound heard by an observer. Means here we have to find out apparent frequency. And given is observer is stationary. Observer is stationary means velocity of observer is 0. V0 is equal to 0. And in this case we have to find out apparent frequency which is heard by the observer. Now let us visualize the condition. Here we'll consider source of sound and the observer. We know the velocity of sound is from source to observer. So we'll consider this is the positive direction. Now in given condition, the car is moving towards the observer. Means the source is moving towards the observer. Means the velocity Vs is positive. This Vs value will be remain same, that is a positive, because it is same as that of the direction of sound wave. Now we know the formula for apparent frequency. Formula is apparent frequency is equal to V minus V0 upon V minus Vs into actual frequency. Let us substitute the values. The velocity of sound V is 330 meter per second minus the velocity of observer is 0 upon velocity of sound, that is 330 meter per second, minus velocity of the source, that is 220, into n. The value of n means actual frequency is 400. After solving this, we will get 1015 Hz. So this is the apparent frequency which is observed by the observer. Now in given case, we have actual frequency is 400 Hz. And apparent frequency is 1015 Hz. Means here apparent frequency is greater than actual frequency. As observer is stationary, but the source of sound is moving towards the observer. Means the frequency heard by observer will be more than the actual frequency value. That's why apparent frequency value is greater than the actual frequency of the sound wave. Thanks for watching this video. Stay tuned with Ekeeda and please subscribe Ekeeda. Thank you.